So today in 3.3 we're going to be talking about perfect squares and perfect cubes. So go ahead and write squares right here and cubes right here. The I can statement for today is I can understand and memorize perfect squares and perfect cubes. So we're going to talk a little bit about the background, how to understand perfect squares and perfect cubes, but there are some that you just need to memorize, kind of like you would times tables, just because it's going to make things much easier in the long run. So as the warm-up question, it says 3 squared equals, and then you've got to put a number right there, and hopefully everybody knows that the number that goes right here is 9. And the question that follows up, it says, why does 3 squared equal the number you say it does, and how do you know that it's right? Well, in order to kind of describe this, we've got to understand what exponents are. So I'm going to finish this next problem right here, and then we're going to talk about why these are the right answers. So this says 3 cubed, 2 cubed, 2 to the third power. So the answer on that one is 8, and here's why both of these work. So what we have here is we have a base and then we have an exponent. We've got a base right here and we've got an exponent. And this base is the number that we use repeatedly in a multiplication problem. So that's what an exponent does. It's a short way to write a long multiplication problem. And the exponent tells us how many times we use that base. So this literally means use 3 twice in a multiplication problem. So 3 times 3 would be 9. And on this one, we've kind of reversed the order here. The base is 2 and the exponent is 3. So that means that we're going to have 2 used 3 times. So 2 times 2 times 2. So 2 times 2 is 4 times 2 is 8. So that's why it is the answer that we said it is. So again, as a reminder, let's go ahead and fill this in so you've got this so that you can refer to it. Exponents tell you how many times you use the base. So write the word base right here as a factor in a multiplication problem. Now I'm going to underline the word factor, and just as a reminder, a factor is part of a multiplication problem. Multiplication. So you've probably talked about factoring before and what factors are, maybe done factor trees or prime factorization or something like that. So a factor is part of a multiplication problem. So that's what an exponent does. That exponent tells us how many times we use the base as a factor in a multiplication problem. So in short, what it does is it changes one factor, that base factor, into many factors. Okay, and the general format of an exponential expression, as we call it, is this. I've used a lowercase b for the base, so b for base. And then this exponent, it's smaller, it's written what we call superscript. So it's smaller and up a little bit higher. That's the exponent. Okay, so if you ever see anything like that, that's an exponential expression. The big number at the bottom, that's the base. The smaller number that's written up here, that's the exponent. So perfect squares and perfect cubes, they're numbers that come up all the time in math, and it's a really good idea to be able to recognize those and have some of those memorized. So we're going to talk about a couple of perfect squares to begin with, and then we're going to talk about why they call them perfect squares. So 1 squared is 1, because this would be 1 times 1. 2 squared is 4, not because we're multiplying these two 2's together, but because that tells us that we're going to use this base twice. So 2 times 2 is 4. Again, we did 3 squared up above, that's going to be 9. 4 squared is 4 times 4, so that's going to be 16. 5 squared is going to be 2 5's multiplied together, so that's going to be 25 right here. And then there's a question right here. It says, why are they called perfect squares? And why do we say squared more often than we say to the second power, to the power of 2, or something like that? Well, there's a good reason for it. So I'm going to draw a little square right here. Okay, as good as I can draw a square, I'm just going to draw a square right there. Well, if this is 1 on each side, that is a square. So 1 is definitely what we'd call a square number. Now, if we say 2 squared is 4, 4 is also a square number, and let me show you why we call that a square number. I'm going to try and draw these sides about twice as big as I did on the other one, and I'm going to cut it like that right there. Let me move this over just a little bit so it looks a little bit better. Okay, so what I have here is that's 1 square, and now if this is 2 on this side and 2 on this side, this is 4 squares right there. Okay, so 2 squared is 4. It's a square number. You can make a square out of it. You can do the same thing with 9. If we made a square that is 3 on each side, 3 units on each side, you can count them up. We've got 9 squares there. And we can do the same thing with 16 and 25, but I'm not going to take the time to draw those. Okay? Now let's talk about perfect cubes. Perfect cubes, we're going to take the base and we're going to use it 3 times. So this would be 1 times 1 times 1. That's going to be 1. We talked about this one up above. 2 cubed is 2 times 2, which is 4, times another 2, which is 8. Okay, this is going to be 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. 4 times 4 times 4. These get big really quickly, get a little bit more difficult. So 4 times 4 is 16, and then 16 times 4 is 64. And then the last one that we're going to talk about right here, this is going to be 5 times 5 times 5. So this would be 5 times 5 is 25, times another 5. So this is like having 5 quarters. If you had 5 quarters, you'd have $1.25. So this is going to be 125. Now, I'm going to draw kind of a visual, kind of graphically, why we call these perfect cubes. And it goes back to this right here. 1 squared makes, if we've got a square 1 on a side, that's 1 perfect square. Well, now we're talking about cubes, so I'm going to draw that same square again. So this is 1 by 1, and then I'm going to draw another dimension to that. So this is 1 here, 1 here, and 1 here. So that is a cube that's 1 on a side. So that's 1 cubic unit, as we'd say. Now, if we did 2, I'm going to start with that same picture that we had up above. Okay. So we've got a square, 2 on each side, and then I'm going to draw and make that look like 3 dimensions. I'm going to add that last dimension right there. And if you look at this, we would have 4 boxes in the front and 4 boxes on the back. That would be 8 right there. So this is a perfect cube because you can make a cube out of it. 8 is a perfect cube because you can make a cube with 8 cubes. And if we did 27, this is going to look kind of like a Rubik's Cube. Now I'm having to draw these a little bit smaller, but you kind of get the idea. So I'm going to draw, there's our square like we had up above. And then I'll add that 3rd dimension to it. So I'm going to draw these right here, and like that, and like this. So you can see that we would have 9 cubes on the top layer, 9 cubes on the middle layer, and 9 cubes on the bottom layer, and then we'd have 27 cubes altogether. So that's why we call those perfect cubes. And it's just a quick, better way to say those, and it also has this kind of geometric or graphic representation. So let's talk about the perfect squares and perfect cubes that you're going to need. So here is a list of perfect squares, and let's come up with these numbers. And some of these, again, we mentioned these up above. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 6 squared, 6 times 6, 36. You might recognize these from your times tables. We'll keep going. 9 times 9 is 81. 10 is pretty easy. 10 squared is 100. 11 times 11, 11 squared is 121. And then 12 squared is 144. Okay, let's keep going here. These probably are not ones that you have memorized, but 13 squared is 169. 14 squared is 196. I do have most of these memorized, so they get a little quicker the more you practice with them. 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And this one I'm hoping you can figure that out. If you had 2 times 2, you'd have 4, but we've got 2 zeros on there, so this is going to be 400. Okay? Now, you may have learned count bys in elementary, or count by lists, like doing your times tables, or sometimes they call it skip counting. This is the same type of thing, except for instead of multiplication tables, these are perfect squares and perfect cubes. So it's a good idea to memorize some of these, and I'm going to draw a little line right to there, and you'll see why in just a few minutes. Okay, so let's do the perfect cubes. Again, 1 cubed is 1. 2 cubed is 8, 3 cubed is 27, because we'd have 3 times 3 is 9, times another 3 is 27. This was 64, and 5 cubed is 125. Now these numbers get really big really quickly. So if we did 6 cubed, that is 216. We could check that on a calculator. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729, and then 10 cubed, that would be 10 times 10 times 10. So we've got a 1 followed by 3 zeros, so that would be 1,000. Now I'm going to draw a line about right there. Okay? Now, you'll see why in just a second. These lists are worth memorizing. So would you please write the word memorizing right there? These perfect squares and perfect cubes come up a lot. You're going to be really happy if you can recognize these when they come up. Or if somebody says, hey, what's 3 cubed or something like that. If you can just rattle off that it's 27, it's going to make things a lot easier. Just like if you have your times tables memorized and somebody says, hey, what's 8 times 7? And you can just rattle off that it's 56. You don't need to think about it for very long. You can just come up with that answer really quickly. I do want you to keep this list right here because we're going to refer to these lists, and it's going to help you memorize these perfect cubes and perfect squares. The only thing that I want you to do as far as an assignment on this is be able to write some of these down and start getting these memorized. Again, the quicker you get these memorized, the more you can recognize these, the better off you're going to be, because these numbers are going to come up over and over and over again. Okay, so I'm going to flip the page over and we're going to write these down. So I'm going to pause for just a second, or you can pause the video, and then you can run through and write those down, and then you're all set. So I'm just going to do this as quickly as I can. The video is going to pause, and then the answers are just going to appear. So take a second, see how many of those you can write down. Okay, I've got those all on there. Hopefully you could do quite a few of them. I did put the line on this side up with the 5 cubed. If you've got memorized up to 12 squared on the perfect squares, then you're in really good shape so far. Those are on your times tables. Those shouldn't take long. The more of these that you can memorize, the better off you are. I can tell you that 15 squared comes up quite often, and 400 comes up often, so that's 20 squared. And then over here on this list of perfect cubes, again, definitely up to 5 cubed, up to 125. If you can do 216, that's awesome. These are really kind of tricky. The 7 cubed, 8 cubed, and 9 cubed, those can be tricky. But if you see 1,000, you should know that that's 10 cubed. So again, the better you have those memorized, the better off you're going to be. So if you can work on that, again, perfect squares to 12 squared and perfect cubes to 5 cubed. That's going to be awesome. All right. Good luck with getting those memorized. They're really going to be helpful.